All right, we're going to continue graphing quadratic functions of the form y equals a times x minus h quantity squared plus k. All right, example 3. This is our second video, part 2. So this is example 3. It says graph g of x equals negative 2 times x plus 2 quantity squared plus 3. All right, so you can see over here that we've got minus h squared plus k. So it's going to be opposite h and the same as k. When I talk about opposite and the same, I'm talking about the signs that go with that to determine the vertex. So you can see the vertex of the graph f of x is hk. So here, hk is your vertex, and the axis of symmetry is still just h. All right, so for the function given, g of x, we've got g of x equals negative 2 x minus negative 2 squared plus 3. Now, why did I write it in this form? Because it's supposed to be negative h, so negative, that means h is negative 2. So if our h is negative 2, our k is 3, that means our vertex is negative 2, 3. So we can go ahead and graph negative 2, 3. All right, we know that's going to be the vertex of g of x. We also know that a is negative 2. Remember, when a is negative, it flips upside down. So we're going to have a reflection here. We're going to have this is going to be upside down parabola. And to find another point, all we need to do is substitute a point to the left or to the right of that into the function. So let's say let x be 0. 0 is always an easy point to substitute in as long as your vertex is not on the y-axis. You can always substitute 0 in. So if I do that, I'm going to have g of x equals negative 2. 0 plus 2 squared plus 3. So I'm going to have negative 2. 0 plus 2 is 2. 2 squared is 4. And I've got negative 8 plus 3, which is negative 5. So I've got another point at 0, negative 5. 0, negative 5. So here's 0. And I know using the axis of symmetry, I can go over 2 units to the left of the axis of symmetry. Remember, the axis of symmetry goes straight down through the vertex. And then we can graph the function. All right, so we have graphed g of x, but it says to compare the graph to f of x, the parent function. So the graph of g opens down, and you can see that it's more narrow than the graph of f, and that's because it's a factor of 2 here. And the vertex of the graph is negative 2, 3, so it's 2 units left and 3 units up from the vertex of the graph of f. So the graph of g, we could say it's a vertical stretch by a factor of 2, a reflection over the x-axis, and a translation 2 units left and 3 units up of the graph of f. Now, B part says, consider function g in part A and graph p of x. P of x is going to equal g times x plus 3. So it's going to take this function here, and it's going to shift the whole thing over 3 units to the left. So 3 units to the left. All right, so I have another function here in blue that's on top of the red one. You can see, so the blue one is going to be the same function as g of x, but now we're going to shift it to the left 3 units. So you're going to look at the vertex and we're going to shift it over 1, 2, 3. So p of x is now this function. We can say the function p is of the form y equals g times x minus h, where h is -3. So all it did was shift me over 3 units to the left. So the graph of p, all you're going to do is subtract 3 units from the x coordinate. Okay, so this inside the parentheses only affects h, not k. So when I move to the left 3 units, I literally took the same function, moved it over to the left 3 spots, and that's my p of x. All right, I'm going to label these for you. So the red one is g of x. The black one is your parent function, or f of x. And the blue one is your new function, p of x. All right, here's a self-assessment. Take a couple minutes, pause the video, see how you can do. Come back and check your answers. It's important to see if what you are watching on the video you actually can put into play on your own. So go ahead and try to graph this function along with the parent function, and then try to answer B part as well. So I'm going to pause the video. I hope you do as well. Try to answer these. We'll come back in a minute with the answers. All right, so P of X is the red graph here. You can tell it's a reflection. This negative means it's upside down. And then the vertex is going to be at 5, -5. So if you come over 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So at 5, -5 is the vertex, and then that is just a reflection of that graph upside down. B part, which one doesn't belong, which function does not belong with the other 3, explain why. If you look at these, this one has a 0 in the parentheses here. That means that is the only function in that group of 4 there that is not a horizontal translation of the parent function. So that one would be the one that does not belong. All right, so this is the last example, modeling real life. The water fountain shown consists of streams of water that are shaped like parabolas. Write and graph a quadratic function that models the path of a stream of water with a maximum height of 5 feet, represented by a vertex of 3, 5, landing on a spot 6 feet from the water jet, represented by 6, 0. All right, so you know we've been using vertex form. So let's look at what we have. So we have y equals a times x minus h squared plus k. All right, so if we have 3, 5, our vertex is 3, 5. So we know this is h and this is k. We also have another point, 6, 0. So this is just going to be our x and our y, just random x, y. So if we plug in h, k, x, and y, that leaves us with one variable, a. So we could solve for that. So let's go ahead and plug that in. So we're going to plug in 0 equals a times, x is going to be 6, minus h is 3, squared plus k is 5. Now, once we do that, let's simplify and solve for a. So we're going to have 6 minus 3. 6 minus 3 is 3. 3 squared is 9. So we're going to subtract 5. So we have -5 equals a times 9, which is the same thing as 9a. Let's divide both sides by 9. A equals -5/9. All right, once we have a, we already know the vertex. then we can write our function. So we can write this as y equals, or f of x equals, it doesn't matter. Let's do f of x. F of x equals a is negative 5/9 times x minus h squared. Make sure you have to have it squared to make it a quadratic. And then plus 5. All right, so it says write and graph a quadratic function to model the path of the water. All right, so let's use our calculators. We're running out of time, so it may help to use our calculators. Let's see. All right, that's the last one we graphed, so we need to go over here and clear this out. All right, so let's graph negative 5/9 x parentheses x minus 3 squared plus 5 graph. All right, what we can do is quickly change our window because this is a window like from before. So let's just do zoom 6. Well, I must have hit a 3 instead of a 2. Let's see what I did. Yes, I didn't hit a 3, but I have an extra x in there. So let's hit that x to make it be gone. And say that did not look like a quadratic equation. If it does not look like parabola, first thing you need to do is go back and quickly look at it and make sure that you did that correctly. All right, now let's check and make sure our vertex is 3, 5. There it is. 3, 5 is our highest point. Good. And then we have another point at 6, 0 and another point at 0, 0. So you can see that that graph represents this function. All right, let's make sure we did everything. Write and graph a quadratic function that models the path of a stream of water with a maximum height of 5 feet. Done. Represented by a vertex of 3, 5. Done. Landing on a spotlight 6 feet from the water, represented by 6, 0. So that's all they ask us to do. We wrote our function, and I used the calculator to graph that. You could graph that with those 3 points. You could graph the vertex, and you could graph this point, and then reflect that across the axis of symmetry to get your third point. And you're going to have a function that looks like this part here in the first quadrant. All right, that's all for this lesson. If you have any questions, please let me know.